We have recently added the EMU calling and provisioning protection feature to the EMU suite. It allows service providers to detect any changes that have been made to their BroadWorks platform, whether those changes are configurations by Compilot, XSI, CLI, or third-party clients. You name it. It doesn't matter what interface made that change. Any changes to the configuration, any changes to the CDRs, or a combination of these in calling and provisioning. We can watch almost an infinite number of permutations. In the CDR alone, there's close to 500 settings that we can detect, or combination of those settings. In Compilot or other interfaces, there's all the settings at the system level, at the service provider level, at the group level, and at the user level. In total, there are about 10,000 settings, and the combination of those 10,000 settings is infinite. The thing that makes EMU CAPP really unique is its ability to understand the context of the change. While there are some tools that can detect a single change, what makes EMU CAPP stand out is that it can detect a context of multiple changes leading up to that single change. It makes it relevant and reduces the number of false positives and only flags what is potentially suspicious or misconfigured. For example, EMU CAPP can detect that one group admin is allowed. So if one group admin is created, it can identify that it conforms to certain naming conventions, but any additional admin is suspicious and not allowed and is flagged. It's not all or nothing like many other tools. EMU CAPP can further analyze if another admin is created and if call forwarding is always enabled and the call processing policies allow the admin to change certain things, then it is flagged. EMU CAPP can understand a lot about the context of the change, not just understand the change and flag it, but also prevent the change. When EMU CAPP detects a suspicious change, it will notify the customer. The customer will either revert the change or disable the group or take whatever action is appropriate. Everything is configurable by the service provider according to their policies. The service provider will be able to decide what action to take and what trigger they're going to be watching for and notified of. Here, I add an admin called evil admin who shouldn't be here because the policy says only one group admin is allowed per group. Now I've added two admins. EMU CAPP allowed the first one I added and didn't flag it, but as soon as I added the second one, EMU CAPP will notify me that there has been another admin created and that it violates the policy. It will flag that change in an email. I can see that there has been an email received notifying me that evil admin was created, which violated the policy. The policy then deletes the newly created admin. So if I go back to my Compilot and refresh it, I can see the admin has been automatically removed by EMU CAPP. So EMU CAPP doesn't just access and watch, it also prevents actions that violate policy. This prevention happens automatically and very quickly and could make all the difference because even a few minutes delay when preventing a hack could be very, very expensive and worth thousands and thousands of dollars for service providers. The fact that EMU CAPP is watching and has the ability to act quickly makes it very effective in stopping these types of fraudulent activities. Any activity on Compilot can be detected. EMU CAPP, it can react to call processing policies. For example, if someone changed the call processing policies in a certain way, then EMU CAPP detects the change, flags it, and then either does something about it or sends out a notification. If I go to my email, I'll see that a notification has arrived that says that there has been a call processing policy change, and it tells me which entity this change was for. This is another differentiator of EMU CAPP. It not only detects changes, it tells us exactly where that change happened and to what entity. Another example, at the user level. If we go to any user and change something like call forwarding always and set it to international, the policy may be that a user is allowed to turn on call forwarding always as long as it is not set to an international number. So if I apply an international number, I have violated the policy, and EMU CAPP is going to detect the change. It figures out that it is being set to an international number, and it will notify the operator or the customer of that change. So if we go back to Compilot and refresh it, EMU CAPP automatically sets that to false. There are many different use cases that can be applied for any settings in Compilot. This could be any of the system settings you can see here. And that's just on the system. Any of these in a service provider setting, or any of the group settings. Any of the user settings or virtual user settings. There are thousands of settings and combinations of settings that can be detected and reverted very quickly. When it comes to the configuration, EMU CAPP doesn't stop there. It goes further into the CDRs and can detect changes in the CDRs. If I switch to something that visually shows me these configurations in analytics, we'll see the number of things that we can detect and trigger. I'll switch the screen to analytics. This is showing client utilization, which is about what devices in the field are being used to make calls. This is not what's been provisioned. This is what's actually been used to make those calls. As you can see, EMU Analytics has access to the information and provides a user interface to plot the data. EMU CAPP also has access to the data and can use anything in here as the basis for flagging and triggering action. For example, this could be any time a customer uses a device that's not in the supported list or an unknown device. EMU CAPP triggers a flag and perhaps assigns intercept to that user so they can't make calls because they're using a device that's not supported. Or maybe they're using an unknown device that's specifically used like a script, which hacks into the system, and so on and so forth. We can also trigger on a large number of call attributes. If we go to the call reporting page, you can see the call reporting analytics shows a number of call attributes. There are about 27 call attributes, but really there are closer to 500 that EMU CAPP can react to. It could be the call type, the call category, the destination number, or the from number, and all other call classifications, whether it's been answered or not. EMU CAPP is triggered when a large number of calls are being made for a specific group or user or service provider, or whether these calls may be made and for what duration of time. EMU CAPP says, are they allowed to make as many calls as they'd like in a day, but not more than 50 calls an hour, or 5 calls a minute, or whatever it is. EMU CAPP uses this information to tell us that this is not a standard call. If we go to the toll fraud page, we can see that we can not just limit ourselves to call durations, but also to what call patterns that are being called. If there is certain call patterns that the call is being made to, and those call types are not specific call types or call category for them, then EMU CAPP can, like EMU Analytics, look for a string match, or a wildcard match, or regular expression match for these call patterns. And whenever something happens during a certain time frame, then it will notify and or go and disable that user, disable the group, or do whatever provisioning change that we would like EMU CAPP to do in response. The number of reactions is almost infinite and includes everything that happens in BroadSource, no matter what the interface, whether it's Compilot, XSI, the phone itself, CLI, or third-party client applications, and also everything about the call, the number of calls in a minute, the volume of calls, the destination of the calls, the patterns, whether they've been answered or not, and every other attribute of these calls. EMU CAPP doesn't just flag it and create custom emails, it also does something about it and prevents potential issues in almost real time as soon as that CDR is produced. In response, EMU CAPP will react to anything deemed suspicious and harmful and prevent that change. There are a large number of reactions. There are off-the-shelf reactions that we recommend the service provider deploy, and they're all configurable. The service provider can also create their own reactions based on a very powerful language that has an ability to combine reactions and apply logic and exit and entry criteria and so forth. I hope this demonstration has provided an understanding of the power of EMU CAPP and how uniquely it can detect the context of a change and how quickly it reacts to prevent a harmful change from occurring.